So again, we should predict what we should see with our trinomials. We should end up with x squared. We should see the middle term should be the sum of those two numbers, so we should end up with 3x, and the last term should be the product of those last three terms. And again, we can see how that happens when we distribute this out. Okay, we know that x times x is going to give us the x squared. Okay, we end up with 5 times x, which is 5x, negative 2 times x, which is negative 2x, and then negative 2 times negative 5 is negative 10. So when we combine the like terms, we end up with plus 3x minus 10. If we show the algebra tile distribute the model for this, we end up with x plus minus 2 along this edge. I'm going to have x plus 5 along this edge. We end up with our x squared tile. Okay, that's our first times first. Our outside 5x times x is going to give us these positive 5x's here. Okay, and then when we do the negative 2 times x, we have our negative 2 times x, which is going to give us a like term of negative x, another like term here of negative x. So we're going to end up here with our 3x's in total, okay, because we have negative 2x's, which is going to cancel with 2 of the positive x's. And then when we multiply the negative 2 times positive 5, we get 10 ones. And because it's a negative times a positive, we're going to get negative tiles in here. Okay, so we get negative 10, and that's the product of those last two numbers. So again, we can see that the middle term is the sum of these two numbers, okay, to get the 3, and then the last term is the product of those same two numbers. So I'm just going to again highlight that. This is my product, okay, here in blue, and in yellow here, this represents the sum of those two parts. So the prediction should explain the positive negative values, because we're going to basically add these two together, because we add this negative and this positive together to get the middle term. And the positive and negative values in the product is justified based on the product of a negative number times a positive number along the length and width. Now we kind of ignored the fact that there's only one x here, and if we have more than one x along the horizontal or vertical, that's going to affect the number of x terms that we have in our product. So if we take a look at this expression here, we have 2x plus 3, so here's my 2x's plus 3. I'm just going to write that in, x, and there's our 3 ones, and then we have, here's our x and 2 ones. And when we multiply this out, notice that we get 2x squared. So that's kind of predictable. But here, when we look at 3 plus 2, well, we don't have 3 plus 2 to give us our x terms here. The product is still the same, 3 times 2, okay, it's going to give us a 6, so the product still is 6, but the sum no longer is a sum of 3 and 2. So here we actually have 7 x's and not the 5 x's that we would have predicted when we just had x's in the front here. So these ones just had 1x and 1x. Once we have 2 x's, now the interactions are a little bit more complicated, because when we distribute this, we distribute to 2 times 2, so that's going to give us the 4x's here, but this x only multiplies this 3. So we have a different thing happening here with the 2's because of the 2 times 2 here, and a different thing happening with the 3. So we have different groups of things. And this becomes a little bit harder to figure out. Okay, when we multiply this out, it is fairly predictable, because we can see 2x, that's our 2x squared. Okay, I'm just going to maybe do this in different colors. When I do my outside, 2x times 2, I get 4x's here. Okay, so I'm going to just write this in. So I end up with 2x squared plus I had 4 x's. Okay, and when I do the distribution here, 3 times x, I get these 3 x's. And then the last times last, here 3 times 2, yeah, that was very predictable. The product is still the same, we still get 6, but now this number is a little bit, doesn't quite work because it's not the same as the 2 because it gets affected by this 2. So now the situation is a little bit more complicated. So we just have to be aware right now that it's a little bit different when we have a number, a coefficient in front. Because now instead of saying that the middle term is 3 plus 2, the middle term is not 3 plus 2. The last term is still the product of 3 times 2, but the middle term now is a little bit more complicated. So we'll have to have another strategy to deal with that, the extra 2 in the front. Okay, so these ones tend to be harder. So the relationship between the number of x tiles is more complicated when we have that a in the front. And that's the key. We have to be careful of that. So for now we want to see just 1x, but when we see the 2x, okay, and when we get a product, the leading coefficient is 2, it's a little bit harder to predict where all these pieces came from.